Welcome to the West Point Cybersecurity Analytics team. So our problem statement: the USMA network holds sensitive information that must be secured and be routinely monitored, such as data in the AMS. Therefore, the West Point Cybersecurity Analytics team is tasked with assessing the security posture of the USMA networks tied to data in the AMS and presenting such information in the dashboard. Our goal is to bridge the gap between the cybersecurity department at West Point and non-technical key leaders. Our product vision: no later than the product's date, develop, implement, and test a system to assess the security posture of AMS and develop a dashboard displaying real-time security risk with the recommendations of multiple courses of action.
As a quick reminder, we have 4 members in this group. We have Cadet Caleb Johnson, Luke Barstow, Deal Cho, and Eric Lowe. Cadet Johnson and Barstow are both IT majors, and Cadet Cho and Lowe are both CS majors. Our Sprint 1 goal is for Sprint 1, our team will create a network map that shows AMS, the locations of various cybersecurity systems within the network, and a sample user of AMS and CIS. This diagram will show no less than 1 hop from each of these systems in the network. The team will also research and find out what security systems are already in place on the USMA network and their locations. Finally, the team will build a basic functional virtual network resembling the USMA network in order to practice security scripting and testing. Our capacity for this sprint is a total of 84 hours. Our total actual logged hours is 85. For our Sprint 1 backlog, we completed basically everything on our initial Trello board. The only thing that we highlighted in yellow was creating a basic script to test the virtual network. This is where Cadet Lowe and Cho, we created the actual scripts necessary to test the virtual network, but we were ultimately unable to actually test the virtual network. So the scripts exist, we just haven't actually used them yet.
So we looked at AMS, and AMS consists of 7 total virtual machines. It's got 2 load balance pairs, one set for CIS and AMS for staff and faculty, another set for everyone who's trying to apply or concerning nominations, and then you've got the external AMS and Redbook on a VM. You've got 1 VM that is really untouched, and all it does is schedule cadet courses and run the algorithms for that, and then 1 VM that is purely for testing and development. Looking at where AMS is located on the network, we learned that AMS is not actually located on any network at West Point, and it exists in the Microsoft Azure cloud. With this, there's a firewall set up that only allows connections from government computers that would belong to cadets and faculty members from the DREN, REN, and NIPRNet at West Point. The plan in the future is to make it so other devices such as cell phones and non-government computers, iPads, other tablets, so they can all connect to AMS from any location in the world. When looking at how network traffic is monitored at West Point, Microsoft Azure collects logs on all the network traffic and then puts those logs into what's known as a log analytic workspace. A way to imagine this is all the data of any traffic across the entire network, logins and other things, is all just, the log files are just stored in buckets, and those buckets are all put into this workspace to be dealt with at a later time by any security administrators. When looking at what is actually going on with those logs, West Point is currently attempting to implement Microsoft Azure Sentinel, although since Sentinel has only been out for a short period of a couple weeks, Sentinel is not fully implemented, and more or less it is currently just sitting doing nothing other than surfing through basic logs on whatever basic implementations it came with out of the box. However, what Microsoft Azure Sentinel allows is all the logs collected in the log analytic workspace already by Azure. It can easily go through those logs and with different workflows and playbooks do things to handle the significant events and anomalies that appear in those logs. Looking on to how we would be able to mimic something such as Microsoft Azure Sentinel on our network, we could begin working with ElkStack. ElkStack is comprised of Elasticsearch, Logstash, and Kibana, and each one allows for different capabilities for collecting the data and then displaying it on a dashboard through Kibana.
Splunk is a security monitoring, cybersecurity analytical tool in which we are able to conduct things such as assess the security posture of a cybersecurity network, and assessing that security posture means identifying potential risks and remediating malicious activity, and identifying different sorts of vulnerabilities within the network that can lead to breaches. We can also monitor different accounts. So we can also maintain a consistent and accurate monitoring process using Splunk's continuous monitoring capabilities. And we're also able to start building a historical baseline for audits and understand the scope and data in our infrastructure. So by this, we're able to kind of build that historical baseline in which we're able to build upon and learn from our previous experiences. Our product skeleton is one where we implement both the Elk Stack and Splunk. So Splunk is basically, in terms of our Westpoint network, the sentinel of log analytical capabilities. Logstash is just a bucket, Elasticsearch can search through that bucket, and Kibana is the visualization tool. But the problem with the Elk Stack is that although with Kibana we're able to actually have those dashboards that has visualization tools, we're unable to actually identify threats and alerts and build that historical database as we mentioned we can do with Splunk. So Kibana can show these things, but it can't actually do those things. So that's why we use Splunk to actually conduct the cyber piece.
So the point of our virtual network was to build a virtual network that resembles the Westpoint network in a basic manner, just with a server and a few clients. The point of this was to be able to run some scripts and test some security protocols in order to test whether our theories and our ideas work in a virtual environment that doesn't threaten the Westpoint network. So originally, we talked to Major about getting a virtual network set up in EEXNet. We asked him for one server and 3 clients and 254 IP addresses. We also required internet access through EEXNet, just in case we needed to download any software or anything like that. He provided us with all of these machines, and you can see them here in our snapshot of vSphere. So this is our virtual network map. As you can see, it's pretty basic. Like I said, we have a server with a fixed IP, 2 clients that are almost admin. One of them's an admin client meant to deal with editing the server and admin operations on the network. The other is a security client where we'll implement security protocols and security software. And the other is just a regular cadet client where we might run some scripts to simulate cadet traffic. As you can see, it's also connected to EEXNet. And we might add some other features in the future, but for now, this is the basic setup. So this is our server. This is a snapshot of the server manager dashboard and a snapshot of our successful ping to the internet. So as you can see, we've set up DHCP, the domain service, and DNS. Not all of these are 100% functional, but they have been set up and they do function to a certain extent. And we are able to access the internet from the server. As you can see from the security client, it does have an IP address given to it by the server. It is dynamically configured, so that's not a static IP address. And it is able to ping the server and the internet through the server. This is our admin client. Once again, you can see that it is being given an IP address by our server. It is dynamically configured for that. And it can also ping the server and the internet. Going forward, our challenges are going to be finalizing all of these systems. So DNS and DHCP still need some work in order to be fully functional. Our security client, so the whole point of having different clients was so that they could serve different purposes, and our security client is going to be used to implement security protocols and possibly some software. So we're going to get that started and start uploading some of that software, try to get it running. The admin client, this is probably where we will end up putting a sample database similar to AMS and testing our security protocols by trying to access it.
Looking at the future of our virtual network, we intend to implement a SQL server similar to AMS. The way we'll do this is to just replicate AMS in its really basic form. So looking at all the admin, client, and security computers, which will all route through the domain controller as it is set up now. They will then be able to reach out to a front-end web application for our version of AMS, which then attaches to a back-end SQL server, which would store all the data that we would replicate for AMS.
For our product roadmap, we have just accomplished Sprint 1. Our next goal is Sprint 2. We want to obtain log traffic from EECSnet with Lieutenant Colonel Morrell approved of us receiving. We want to begin implementation of our Elk Stack and Splunk tool. For Sprint 3, we want to implement a dashboard and determine which analytical information we want to display. For Sprint 4, we want to give our analysis tool real-time and log traffic to test our capabilities. For Sprint 5, test our dashboard and real EECSnet data outside of our network.
This concludes our Sprint 1 video. We will take any questions at this time.